which is the last type of calculations, is I've put them together. It's like milli equivalents, millimoles, specific gravity, density, osmolarity calculations. So I put all of them together. Now for these calculations, you need to know the equation of it. You need to know the formula. Okay? If you know the right equation, then it's just a matter of putting everything in the equation and everything is easy. So what I'm going to do now is I'm going to write the equations which you need to note down. Okay? So what's the equation, if somebody remembers, for the density? Density is mass per volume, if you remember.
Yes.
So it's grams over mils. And actually specific gravity has the same equation. So that's density specific. The other thing is millimoles. We covered this equation yesterday. Millimoles is equal to weight in grams divided by molecular weight. That's to calculate millimoles. And in the same way, milli equivalent is the same equation. How to calculate the milli equivalence is the weight in grams divided by molecular weight, but you multiply it with valency. Now valency depends on the compound. For example, sodium carbonate or calcium carbonate, sodium bicarbonate. So valency depends on the compound. Okay, so that means that the compounds for which now you can note here that the compounds which have the valency 1, for those compounds, millimoles and milli equivalents are the same. Okay, you can see from the equation that for the compounds which have the valency 1, like sodium bicarbonate, sodium chloride, they have valency 1. So for these compounds, milli equivalents and millimoles are the same. The other important thing, the last equation, is for the osmolarity. No, I don't remember the equation as well. So it's weight, and this should be in grams per liter, divided by molecular weight, multiplied by number of particles. Number of particles, I'll talk about that in a minute, what that means. Multiply by 1000. That's the equation for osmolarity. Milliosmol per liter is equal to weight in, it should be in grams per liter, divided by molecular weight times number of particles times 1000. Now number of particles here means that how many particles the compound, when you dissolve it in water, how many particles it dissociate into. For example, sodium chloride, when you add in water, it dissociates into two things, sodium and chloride. So sodium chloride will have two particles. The same way sodium bicarbonate will dissociate into two, sodium and bicarbonate. Right?
Yes.
Any other example? What about calcium chloride? 3. Because it's CaCl2. So that in calcium chloride, this is the formula for calcium chloride. So there is 1 calcium, 2 chloride ions. So when you dissolve in water, it dissociates into 3 particles. Sorry. So millimoles is also weight in milligrams by molecular weight, milli equivalent also, because it's milli, M here. So that's why it's milligrams. Now, how many milligrams? Okay, now look at the question and apply the right equation. So when I deal with these type of questions, I write down the equation first and then try to fit everything in that equation. and then it becomes like automoles. Okay. So how many milligrams of sodium chloride present in 0.25 millimoles? So it's like millimoles calculation. Millimoles is weight in grams divided by molecular weight. So weight in milligrams is given here? No. That is what I have to find out. So, but I have been given molecular weight and 0 millimoles. So it's 0.25 millimoles. So I've just written the equation and I'm trying to plug everything in the equation. 0.25 millimoles. Weight I have to find out in milligrams. And molecular weight is also given. It's 58.5. Okay, so what would be the weight in milligrams? .25 divided by 58.5. Okay, so this is the answer. The next question, how many grams of sodium chloride should be used to prepare the following solution? Okay, now this is the solution given. And how many grams of sodium chloride I have to find out? It is millimoles equation. So the first thing I will do, I will write the equation. Okay, now in this solution, for which I have to find out the number of grams I have to make, in this solution is 60 mils. And each 5 milliliter of this solution has this many millimoles. So first of all, I should find out how many millimoles are present in the total solution. Okay, so if 5 mils contained 0.6 millimoles, 60 mils will have 7.2. So because this information was given here that every 5 mil of this solution has 0.6 mils and the total volume of this solution is 60 mils, so I have just worked out how many millimoles will be present in the total solution. So now I know the number of millimoles, I can plug them in this equation again. 7.2, weight in grams, milligrams I have to find out. Molecular weight is given. $400. 421 milligrams, and I have to convert that into grams. So that will be 0.42 grams. So that's the answer. Because they asked in grams. Is everybody with me? So far you have seen that if you just write the equation and try to plug the values in equation, then it's like on autopilot mode. A 20 ml vial is labeled as KCl 2 milliequivalent per ml. How many grams of KCl are present in this vial? Milliequivalent equation is equal to weight in milligrams divided by molecular weight times valency. So milliequivalent per liter, I know that this 20 mils vial and the strength is 2 milliequivalent per liter. So can I work out how many milliequivalent are present in this? Come on, 2 milliequivalent present per mil, and this vial is 20 mils. So how many milliequivalent would be present here? 40. 40? Is that right, everybody? 40 milliequivalent present in the vial. And I have to find out how many milligrams. Molecular weight is given here. So milliequivalent 40, weight I have to find out. Molecular weight given 74.5. So the same way, valency of KCl is 1. Okay. Weight It's 2980 milligrams, but the question is asking how many grams, so I would just convert that into grams. No, valency will not be given in these. For the common compounds, okay, I can make a list of the common compounds like KCl, potassium carbonate, calcium carbonate, sodium bicarbonate, and I can give you the valency of the common compounds. Okay, how many milli equivalents? Again, the milli equivalent equation. So let's just write the equation first. Weight in grams, milligrams, molecular weight. Valency. So how many milli equivalents we have now? We have to find out. So this is what we have to find out. Weight in milligrams, we have to put in equation. So how do I find out weight in milligrams here? Yes, I use this information. 10% weight by volume means 10 grams in 100 mils. But this solution is 12 mils. So if 100 mils has 10 grams, 12 mils will have 1.2, but this is grams. Okay, the formula needs milligrams. So let's convert this 1.2 grams into milligrams. What would, going from a bigger unit to a smaller unit, decimal is going to move towards right. 1, 2, 3. So it's 1, 2, 0, 0. Right? Plug that in the equation. Molecular weight is 74.5. Now, osmolarity. What is the osmolarity of normal saline? If you have worked in the hospitals, you know that normal saline is 0.9% sodium chloride. That's the normal saline. So let's write down the equation first. This is number of particles times 1000. Can we plug the values in the equation? Weight, I need grams in per liter. Where do I get that from? From this equation. From this information. So it's 0.9% sodium chloride. That means it's 0.9 grams in 100 ml. So in per liter, yes, very good. So if 100 ml has 0.9 grams, 1000 mils or 1 liter will have 100 mils has 0.9, so 1000 mils will have 9 grams. So I've got the values here now. I can plug them in the equation. Weight, grams per liter is 9. Molecular weight is given here, 58.5. Number of particles will be 2 because it's sodium chloride. So sodium chloride will dissociate into sodium and chloride. Is that okay with everybody? Should we move on? Okay. The next question, what is the osmolarity of dextrose, what is the osmolarity of D5W? Now again, those who have worked in the hospital, they know that D5W is dextrose 5%. So we have to find out what is the what is the osmolarity of dextrose 5%. So again, write down the equation first. So weight in grams, how do I work out weight in grams? From this equation. So 5% means it's dextrose, 5 grams is present in 100 mils, has 5 grams of dextrose. So 1000 mils will have 50 grams of dextrose. So I will plug 50 grams here. Molecular weight is 198. Number of particles for dextrose is 1. Okay, everybody? So we have done milli-equivalent equation, we have done millimoles equation, and we have done osmolarity equations. The next two are very quick. The next four are very quick. It's just the density and the specific gravity. Okay, so density equation is, density is 1.25. And volume we have to find out, right? So just rearrange this equation. Type, what is the weight of 0.5 liters of propylene ethylene glycol 400, specific gravity is 1.13. So again, specific gravity is the same thing, mass over volume. Specific gravity is given here at 1.13. Volume is in mils, mass is in grams. What is the weight? That is what I have to find out. Volume is 0.5 liters, so that will be 500 milliliters. Okay, so just rearrange that equation. Okay, everybody? 565. That will be grams. Okay, everybody? Okay, with this we have finished this type of equations as well. Again, remember milli-equivalent, millimoles, osmolarity, specific gravity, density. Just write down the equation first, and then it carries on from there.